This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 10, the airside capstone. No new formulas. You already own duct pressure and the friction chart, the fan laws and the operating point, air distribution and filtration, ventilation and mixing, and energy recovery. This lesson is the method under exam pressure. Name the quantity, route it to its printed equation, and solve. We'll work 4 problems: a duct's velocity pressure and friction rate, a fan speed change, a mixing and ventilation pair, and a heat recovery ventilator. Then lock in the week's traps. The decision map. Every airside problem is one of a few shapes, so name the quantity first. Need a duct's velocity pressure? Velocity is flow over area, then velocity pressure from the standard air shortcut. Sizing to the friction chart? Convert a rectangular duct to its round equivalent, then read the rate. A fan speed change scales flow, pressure, and power by the first, second, and third power of the speed ratio. Mixing gives a flow-weighted temperature. Ventilation adds a per person and a per area term. And heat recovery rides one effectiveness. Identify the shape, reach for the equation, solve. Problem 1. A duct. Area is 2 square feet, so velocity is flow over area, 1,500 feet per minute. Velocity pressure from the standard air form is about 1/1400ths of an inch. To use the friction chart on a rectangular duct, first convert to the equivalent round diameter, about 18 inches. Then enter the chart at the flow in that diameter to land on the 0.20 design rate. Over a 100-foot run, that's 2/10ths of an inch of friction. One trap. Velocity pressure uses the actual duct velocity, not a velocity built from the equivalent diameter. Problem 2. A fan sped up 20%, from 900 to 1080 RPM, a ratio of 1.2. Flow scales with the ratio, 9600 CFM. Pressure scales with the square, 2.16 inches. Power scales with the cube, 5.2 horsepower. 20% more air, but 44% more pressure, and 73% more power. The cube on power is what bites. Problem 3. Mixing and ventilation. Mixed air temperature is the flow-weighted average. A quarter of the outdoor 95 plus 3/4 of the return 75 gives 80 degrees. Breathing zone outdoor air is the per person rate times people plus the per area rate times floor area. 250 plus 300, 550 CFM. Problem 4. A heat recovery ventilator in winter. Effectiveness 0.7. Outdoor air in at 10. Exhaust in at 70. Balance streams. Leaving supply is the inlet plus effectiveness times the 60-degree difference. 52 degrees. Recovered sensible rate is 60 times effectiveness times the minimum mass flow times the specific heat times the temperature difference. About 90,700 BTU per hour. Balance flow drops the exhaust, the same 42 degrees, to 28. The week's traps in one screen. On constants and exponents, velocity pressure has a general form that needs density and a standard air shortcut that already bakes it in. Never swap them. Fan laws, same fan, go flow to the first power, pressure to the second, power to the third, and never to diameter. And convert CFM to pounds per hour with the long 60-row form, not week 2's collapsed factors. On mixing and recovery, energy recovery always divides by the smaller stream's mass flow, and sensible rides temperature while total rides enthalpy. Mixed air temperature is flow-weighted, and breathing zone air needs both the per person and the per area term. Cross-topic check. A refrigeration ton is 12,000, a cooling tower ton, 15,000. Look up discipline. The duct pressures and the friction chart. The fan laws, curves, and power. Air distribution, mixing and ventilation, filtration, and energy recovery. Every one has a homepage. Know which section owns the quantity. Jump to it, read the row, and confirm. Never search from scratch under the clock. The method and the clock. Before you compute, name the quantity, duct pressure, a fan law, a mixing or ventilation rate, or energy recovery, because that alone picks your formula set. For a duct, velocity then velocity pressure, and convert to the equivalent diameter to read the chart. For a fan, take the speed ratio, then flow, pressure, and power by the first, second, and third power. For mixing and ventilation, a flow-weighted temperature, and the per person plus per area airflow. For recovery, the leaving temperature and the recovered rate. Keep the units the formulas expect. And if a method isn't printed, the problem gives you the number. That's a wrap on Week 4, the air side. 10 lessons: duct design and the friction chart, static regain and system effect, fan laws and curves, fan selection and the operating point, air distribution, filtration, ventilation and mixing, energy recovery, the pressure budget, and this capstone tying them together under time. More HVAC weeks are on the way. Subscribe so the next one reaches you. Everything's at PEPrepengine.com. A cheat sheet, worked solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide with every equation and common exam trap is free at PEPrepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.